welcome to True Projects. In this video, we are going to explain about the project title, which is Machine Learning Algorithms for COPD Patients Readmission Prediction, a Data Analytics Approach. This project is centered on improving healthcare outcomes for individuals suffering from chronic obstructive pulmonary disease, which is COPD. Given that COPD is a leading global cause for mortality and places a substantial burden on healthcare systems. This project is driven by the need to reduce hospital readmissions within 30 days of discharge. To achieve this goal, advanced data analytics techniques such as decision trees, artificial neural network, and support vector machine are leveraged to identify high-risk COPD patients who are more likely to be readmitted. This initiative equips healthcare professionals with data-driven insights, empowering them to deliver targeted care, elevate patient burdens, and optimize the utilization of healthcare resources, thereby enhancing the overall quality of patient care and reducing healthcare costs. The primary objective of this project is to harness a diverse range of machine learning algorithms, including SVM, random forest, decision trees, logistic regression, voting classifier, XGBoost, ANN with MLP and Namebase to construct a robust predictive model. Specifically, the project focuses on forecasting readmissions among COPD patients, addressing a crucial healthcare challenge. Through the strategic use of these algorithms, the project aims to accurately identify individuals at high risk of readmission. The ultimate goal is to furnish healthcare stakeholders with actionable insights, facilitating targeted interventions and more efficient allocation of resources. This comprehensive approach is poised to enhance patient care, lower hospital readmission rates, and mitigate healthcare costs, delivering valuable insights to healthcare ecosystems. Coming to requirements, we need hardware requirements. In that, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. Coming to flow of work, we have designed few modules to execute the project. In that, the first one is importing the packages. In this module, we import the necessary Python libraries and packages required for data analytics, machine learning and web development using Flask. In that, we imported NumPy, Pandas, Scikit-learn, TensorFlow, Keras, Seaborn and Matplotlib. Second one is exploring the dataset. This step involves loading and exploring the COPD readmission data. In this, we perform tasks like data loading, checking for missing values, and gaining a preliminary understanding of the dataset structure. Coming to data processing, in that, drop cleaning. Here, we perform tasks like data pre-processing, dropping irrelevant columns or cleaning the data to make it suitable for analysis. Coming to visualization data using Seaborn and Matplotlib, data visualization is crucial for understanding patterns and trends in the dataset. This module involves in creating visualizations using libraries like Seaborn and Matplotlib. Coming to label encoding, here the dataset which contains the categorical data has to be converted into numerical format for machine learning models. Label encoding is one way to achieve this. In that, the changing string to integer, which means we need to change string values to the integer values. Coming to feature selection, this step involves we select the features, attributes that will be used for the model training. It involves choosing the input features as X and the target variable as Y. Coming to the seventh one, which is model building, this is a critical part of this project where we create machine learning models. In that, the first one is support vector machine. It is a supervised machine learning algorithm used for classification and regression. It finds a hyperplane that best separates data points into different classes. It is used to classify COPD patients into high risk and low risk categories based on their health attributes. It is valuable for its ability to handle complex data and high dimensional feature space. Next one is random forest. It is an ensemble learning method that combines multiple trees to make predictions. It is known for its robustness and ability to reduce overfitting. Random forest is employed to capture complex relationships within COPD patient data. It contributes to prediction accuracy and handles feature importance well. Coming to next one, which is decision tree. Decision tree is a tree-like structure where an internal node represents a feature, a branch represents a decision rule, and a leaf node represents an outcome. It is used for both classification and regression tasks. Decision trees help to visualize and understand the factors contributing to COPD readmission. They are useful for making binary predictions based on patient attributes. The next algorithm is logistic regression. It is a statistical method used for binary classification. It models the probability of a binary outcome as a function of one or more predictor variables. Logistic regression is employed to model the likelihood of COPD patient readmission based on their health attributes. It provides a probabilistic view of outcome. The next algorithm is voting classifier. It combines SVC, random forest and decision tree. It combines predictions of multiple machine learning models and chooses the majority class as the final prediction. Voting classifier combines the strength of support vector machine, random forest and decision trees to improve overall prediction accuracy and robustness. Coming to XGBoost, it is an extreme gradient boosting, which is optimized gradient boosting algorithm used for classification and regression. It is known for its speed and performance. It is utilized to create a strong ensemble model that can capture complex relationships and provide accurate predictions for COPD readmissions. Coming to ANN and MLP, which is Artificial Neural Network and Multi-Layer Perceptron. It is a machine learning model inspired by human brain. An MLP is a type of feed-forwarded neural network with multiple layers of interconnected neurons. MLPs are used to deep learning to uncover intricate patterns in COPD patient data, making them suitable for complex prediction tasks. Coming to Naive-Bayes algorithm, Naive-Bayes is a probabilistic classification algorithm based on Bayes' theorem. It assumes that features are independent of each other. Naive-Bayes is used for its simplicity and speed in making probabilistic predictions about COPD readmissions based on patient attributes. Coming to training the model, after selecting the models, we train them and we prepare for a dataset. The models learn from the data to make predictions. The next one is Flask framework with SQLite for sign up and sign in. This module involves setting up a web application using a Flask. We integrate SQLite database to manage user accounts for sign up and sign in functionalities. The next one is user gives input. User interact with the web application by providing input, in this case, likely information related to COPD patient. The next one is given input preprocessed with trained model. The input data provided by the user is preprocessed to match the format expected by the trained machine learning models. Then, the models are used to predict the likelihood of readmission based on the user's input. Coming to the last module, which is final outcome display, the prediction or the outcome from the machine learning models is displayed to the user via the web application. This outcome could be a probability score, a binary prediction, or any relevant information. Coming to comparison graph, here on the x-axis we have the accuracy score and on the y-axis we have the algorithms. Here, this bar graphs represent that the accuracy score of that particular algorithm. Here we can observe that the voting classifier's accuracy is high than all other algorithms. Coming to execution, we need to open the code folder. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file, which contains the algorithm information, and this will be loaded into the project code during runtime. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign up file. This file is a database file used to store the information. Now we need to copy the path which is displayed in the address bar of the file explorer. And now we will open the Anaconda prompt. Here we need to use the cd command followed by the space and paste the copied path. This will change the command which is used to change the current directory to the code folder's path. So The current directory is changed to the code folders path. Now we need to type python space app.py. This will compile app.py file using the command python space app.py in Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now I will hit enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this one, and the port number, which is this one, unless configured differently. Now we have to copy this local link provided by the Flask framework and paste it in any browser. I prefer Google Chrome, so I will paste it in the Google Chrome. So I will paste it here and click on enter. This has redirected to the home page of the project, which is displayed in the browser, and this is the front end built using the Flask framework. Now we will click on sign up. Here we need to fill all these details if we are registering newly and then log in. I have already registered, so I will directly log in. For that, I need to click on sign in. I need to give my credentials, which are my username and the password. Now I will click on the button submit. So this has redirected to this page where I need to fill all the patient related details and then click on submit. By that it will predict the disease of that particular person. Now we will enter step by step all the details. So we will select discharge position as home and gender as male and race as white, diabetes mellitus as DM, chronic kidney disease as non-CKD, anemia as anemia, and chronic obstructive disease as COPD. And the age we will enter as 58, and the chronic disease count is 18, and the length of the stay is 3, emergency visit is 16, total visits is 45, BMI is 51.48, BP dialytic as 0, BP systolic as 0, temperature as 0, heart rate as 0, pulse rate also 0, and all other things are also 0, which is respiratory rate, ACE inhibitors, ARBs, beta blockers, directress, total medicine, cardiac troponin, hemoglobin, serum sodium, serum creatine, BNP, and the last one is NT-proBNP. Now I will click on submit. So it has predicted that based on the given information, the patient will come to the hospital for readmission within 90 days. Now we will enter all other details of other patient and then see what will it predict. So we will choose the level as SNF and gender as male and the race as white, diabetes as DM, chronic kidney disease as CKD, anemia as he has anemia, chronic obstructive disease as no COPD, and the age as 57, and the chronic disease count is 13, and the length of stay is 20, 7 as emergency visit, total visits as 21, BMI as 30.4, BP diastolic as 83.07, BP systolic as 133.3, temperature as 97.8, heart rate as 69.9, pulse rate as 0, respiratory rate as 31.7, ACE inhibitors as 0, ARBs 1, beta blockers as 0, this one as 0, and the total medicine as 1, and the cardiac troponin is 0, hemoglobin as 9.9, serum sodium as 0, serum creatinine 9 as 0, BNP as 0, and the last one, which is NT-prop BNP, is also 0. Now we will click on submit. Here it has predicted that based on the given information, the patient won't come to the hospital for readmission within 90 days. In this way, we can enter the patient details and then see whether he will be readmitted in 90 days or not. Now we will sign out. In this project, a diverse range of machine learning algorithms including SVM, random forest decision tree, logistic regression, voting classifier, XGBoost, ANN with MLP, naive Bayes are harnessed to predict readmissions within COPD patient population. Notably, the voting classifier as a part of an ensemble method substantially improved prediction accuracy. These advanced techniques provide highly effective in identifying high-risk patients, enabling healthcare providers to deliver targeted interventions and allocate resources with precision. In summary, this approach holds great promise in reducing COPD-related hospital readmissions, enhancing the quality of patient care, and ultimately mitigating healthcare expenditures.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.